In this video, we will walk through the Oracle tutorial, Interfaces and Inheritance. So let's get started. Interfaces, in essence, is a contract. If two business parties want to make business, they need to agree upon a common contract. In the software world, that contract is called interfaces. So if two programs need to work each other, they have to know what kind of input-output they expect. And so let's take a look at an example. Here, imagine a futuristic society where computer-controlled robotic cars transport passengers through city streets without a human operator. Okay, no human operator, better or worse. Automobile manufacturers write software. Who is those automobile manufacturers? They are BMW, Toyota, Chevrolet, and they manufacture cars. So what their car can do, their car can stop, start, accelerate, turn left, and so forth. So that's all the car does. If your car cannot do those things, you cannot call your car a car. That's industry standard. All the manufacturers, the car can do those things, no matter they are Toyota, BMW, Chevrolet, or GE, or whatever. GM, okay. Another industrial group, notice another industries group, electronic guidance instrument manufacturers, make computer systems that receive GPS position data and wireless transmission of traffic conditions and use that information to drive the car. So there's another industry which is still not there yet, but what they do is they receive position from GPS and they use that information to drive the car. Today the GPS drive you and you drive the car. In the future, okay, the GPS drive a robotic and the robotic drive the car. That's what those guys do, the electronic guidance instrument manufacturers. They use GPS to drive the robotic instead of drive you, what is happening today. Okay, so the automobile manufacturers must publish an industry standard interface that spells out in detail what methods can be invoked to make the car move. Any car from any manufacturer. So there is the industry standard for all the manufacturers. And the guidance manufacturer can write software that invoke the method described in the interface to command the car. They don't care what manufacturer they are, as long as they obey the contract. They are in the business, they can drive by the guidance manufacturers. So let's take a look at this example. Let's copy this into Eclipse. New Java project, Oracle tutorial, new package, session 1. Already exists. Why? Session 0. Okay. Already have session 1. Oh, let me delete this. I don't want it to be around. Session 0. New interface. Okay, first thing is we need to create this direction. New Elon direction. I need two directions, left and right. Next thing is to remove those and I change the combination unit. Okay, now we have the interface. So what the interface tells us, the interface tells us what a drivable car should be. So it needs to do those basic functions: turn, change turn, signal, and when you're trying to turn, the clients need to tell me what direction do you want to turn, left or right. what the radius, start speed, and end speed. If you tell me those things, I promise I turn the car. Okay, and that's a contract between the customer and the car manufacturer. Again, if you signal the turn, if you tell me what direction you want to turn and you want to turn the light on or off, if you tell me those things, I honor my promise to turn the signal on my physical car. Okay, this is your requirement. This is what you expect me to do. This is my receipt. I return you an int. The interface didn't say what int you want to return, but I can return you anything what light I turned or the wattage, whatever, which I think meaningful. And but the interface didn't say, so it's flexible. Also, the interface didn't say is exactly what how you should implement the signal turn. It only say only specify the signature, didn't say exactly how you should turn. So it's depend on you. You can do nothing, which is permitted by the language, but then you are a rogue manufacturer. Okay, you make a bad promise, and you made a bad manufacturer, and probably soon out of business. But this is a contract they say. It defines and what it didn't define. Okay, the next thing is now BMW 701i. This luxury car want to be the pioneer in this area, so it first changes car to be drivable by robots. In order to do that, it needs to implement the industry standard, the operate car interface. So let's create that class. New class. And copy the code in, change the compilation unit, rename, and now BMW agreed to implement the interface. So in order to implement the interface, it's like to agree a contract. If you agree a contract, you have to accept the contract as a whole. You cannot just agree this part, don't agree those part. If you sign a contract, you agree all of those things. So this is what happens here. You have to implement all the implemented methods. You need to turn, change, learn, everything. Here we still have a red line because we didn't return anything. We return 0. Okay. And again, you need to make this public so that it overrides abstract method. The abstract method in the operated car, the scope is public. You cannot make it less. So you have make it broader or equal. So public is fine. If you don't specify anything, that's default package level, which is less visible, which is unacceptable. So you make it public. And now operator BMW honors the contract, promise honor the contract, but this is an empty promise. You didn't do anything except to return 0. You need to change those commands into physical action. How BMW do that? They have a library to interact with their physical car. That's their secret. They generally give you a library and want to give you the source code. They give you an encrypted library, and their magic happening in that library. So let's simulate that jar file. So what's happening here? They probably have I don't know, public static void like core The operating system, let's say, it's probably, let's guess, it's a micro C, Unix. That's their operating system on the car. So, and what they do is they probably do other things. They process input, and then they core um, core another, not public, this time private static void, core hardware driver. And they have ints like the driver number, driver ID. Okay. Then they do fancy things like turn wheel, flashlights, siren, etc. Okay, this is how the software changes to the physical movements inside here, the core hardware driver under the hood. And after a big sort, turn it to 0. So this is a BMW. They passing those directions into their library method. And after a deep sort, they think you want core driver 0, then they core it and change your command into physical action. And so let's do that. Lib BMW core this. Um, and here, since you core this, let's give you a receipt. Print out, print line. Hello from BMW. Okay. Now the BMW is drivable by the GPS, and Toyota say, okay, that's fancy new technology. I also want to like implement this promising industry standard. So Toyota now try to get into this business. So the first things they will write this class. Camry, okay, and it implements the operate car. Okay, since they operate car, they agree upon the contract. Now you need to public operate car. Let me copy this. They need to implement all the methods specified in the standard, in the contract also. Okay, now they want to turn. They have their own secret jars. Like the BMW, they have their own secret jars. Let's simulate with nib Toyota. Okay, here they do the similar things. Nib Toyota, let's retype it in. Public static void. Let's say core Arduino. Okay, they use Arduino, and instead of passing the parameter, they use a command code. They could have a different implementation. So get that command code. Use command code to do hardware software interactions. So they just call the Arduino and do the magic. They have different implementation. And here, let's go back to the Toyota Camry. So here they could say if direction equals direction left, direction yeah, direction left, and oh, and oh, I don't want to implement this one. I want to implement a simple one, the same as PMT. So signal turn here, signal turn, and signal on. If you this situation, you want to nip Toyota core Arduino commands code 0 else you call the same library with different command code. Okay, then you also turn your signal. So here the same thing. Let's print out a receipt from the proprietary library code of Toyota. Hello from Toyota. Now we have two manufacturers, both implement the same contract. That's what the example is trying to say. In the robotic car example above, it is automobile manufacturers who will implement the interface, which is, in our example, Toyota and BMW. They implement the same interface. Chevrolet's implementation will be substantially different from that of Toyota, of course, but both manufacturers will adhere to the same interface. They also agree upon that operate the car. That's the industry standard or contract. The guidance manufacturers, who are the clients, the guidance manufacturers, okay, this guy will come into a thing soon. Who are the clients of the interface? We build systems that use GPS data on a car's location, digital street maps, and the traffic data to drive the car. In so doing, the guidance system will invoke the interface methods turn, change, lane, brake, accelerate, and so forth. So let's build this guidance manufacturer. Okay, so the first guidance manufacturer in this industry is called big data GPS. Okay, let's say it's big data GPS. It's the first such kind of robotic driver company. And let's write a public static void main string x. Okay, so this is pretend this is a pilot drive. Okay, so they have a void pilot robot. What the pilot robot is doing is they have a while loop. Okay, while 2. And they in this while loops they just they will get a GPS position. Let's say let's create an inner class position. In this position we have int x y and public position int x int y. This x as x equal x, this y equal y. Okay, we have a position. So then we have a class return a position, get GPS position, and return. Let's return new position. Let's say it stays there, didn't move, so we always return 0 and 0. New position. Okay, and so in this while loop, what it's doing is, and we have another void drive sequence demo sequence. In this demo sequence, we accept operate car op operate car. We accept this interface, then we drive that and turn signal, signal turn. Okay, direction left, and turn 2. We don't do anything because this is a pilot. We just to make sure we can flash the light. And Alright, 2. So this robot, in the while loop, the robot is first to get a GPS position. After they get a GPS position, then it's turn the lights on. You need a new, so here, let's create operate car. Interface, you need an interface type. Let's say our pilot car is a BMW. We use this car in our pilot demo. So and let's run this car. Big data, GPS, BG equal new. Right. Okay. Yes. Okay. Then let's BG core the robot, core the pilot robot. Okay. Let's run the program. Run as Java application. You see, we see hello from BMW, which is from the BMW library. Hello from BMW. So this pilot drive is succeed. Now we have BMW working. Let's say, let's try Toyota, because Toyota is also promised to implement the same interface. So we just need to change it to operate Toyota Camry. And let's run the program again. Okay, this time we see hello from Toyota, which is from the Toyota's library. Or their implementation. We changed the implementation without touch the interface. Okay. Big data GPS. We just changed this line from the operate BMW to operate Toyota Camry, and we get a new implementation. And all we pass around is the interface. So no matter, the GPS company don't have to know what kind of manufacturer you are. As long as you obey the same contract, the same industry standard, we can drive you. You are in the business. That's what is the power of interface in a Java program. In the next section, we will continue with define an interface, implementing an interface, and so on and so forth.